All right, let's get after it. Chapter 7 review, part 2. We got word problems, SAT style, Regents exam, and so on and so forth. All right, number 1, a flagpole casts a shadow 16.6 meters long. So I'm going to go ahead and draw my ground. Got the flag. The shadow is down here on the ground. All right, sorry about that. I had to recalibrate this thing. So my shadow's down here on the ground. There's actually a line here that we don't really see, but we'll just draw it to make our triangle. And Tim stands at a distance of 12.45 meters from the base of the flagpole. So this shadow, actually I'm going to redraw this just so it's not quite so crowded. I'm going to make the shadow on the ground a lot longer. We're going to make it go way out here. 16.60 long. Now I'm going to draw in my small little line. Well, Tim is going to stand at a spot right in line so that his shadow lines up perfectly and ends at the exact same spot. So that's kind of what this part where it says the end of Tim's shadow meets the end of flagpole shadow. So you kind of have overlapping triangles. And I'm going to put in the other measurement. He's 12.45 from the pole. So that stops a little bit short there. So what we can do right now, we can subtract those two numbers to find his actual shadow. 16.60 minus 12.45 would be 4.15. So that's kind of right to the end here. We'll need that in a second. Tim is 1.65 meters tall, and we don't know how tall the flagpole is. So basically, cutting out all the extra fluff, we have a triangle inside of a triangle. Sometimes you can use a side splitter if you're talking about the sides, but we're actually not here. So what I'm going to do is I'm going to divide and conquer. I'm going to kind of grab this little Tim triangle. And I know the dimensions for that. It's 4.15 and 1.65. And then I'm going to do the actual flag triangle because I have the numbers there for that. And that's 16.6 and that's X. So the 12.45 actually is not going to show up in our proportion. So I bust out my proportion. I'm going to just go little height over big height. Little shadow over big shadow, and I cross multiply, which I'm going to kind of leave out the algebra step there. And let's see what we get. Looks like we get about 6.6, and we're talking about meters on this problem. So number 1, 6.6. All right, let's go down. The aspect ratio of a TV is the width to the height. So a normal television, common aspect ratio is the width, so this will be our width, is 16, and the height, which is 9. And, this little ratio, dot, dot, can just be put as a fraction also, 16 over 9 for width over height. The length of the diagonal is the screen size. So if you want to find the screen size for a television, you actually have to know the diagonal size here. So it says, determine and state to the nearest inch the screen size. What is the diagonal of a flat screen television that has a height of 20.6? So this one's quite a bit bigger. And the height of this television is 20.6. I don't know this bigger width. So I'm going to set up a proportion right now. We didn't really need this. So let me get a proportion just to get that big W. So I'm going to do little width over big width, little height over big height. Crank that out, do a little bit of work. And again, I'm going to save the algebra. But for a W, I'll get 36.6 when I round it, inches. And so now the ultimate question is, find the diagonal or the screen size of this television. So it's just a Pythagorean theorem problem since it's a rectangle. I can transfer this down here. So basically I have the length squared plus the width squared equals the diagonal or screen size squared. When I put all that together, I got 1763.92. And then to solve a squared, to undo that, I take the square root. And we got about 42 inches. All right, next problem. We have a surveying problem. We're trying to find the distance across the pond from B to C. So my ultimate goal here is to find this measurement. So I don't see any other x's in the diagram, so I'm going to go ahead and just call it x. And I notice I have nested triangles again. I have this large triangle, and then I have this smaller triangle. And basically, we can measure the distance across the lake by measuring a couple ground distances. Like all three of these, we could actually walk on the ground and measure, but we can't kind of measure across the water like that. So we're going to use similar triangles to do that. So I have a small triangle. It's pretty big, but it's the smaller one. And that one is 120 by 230. And then we have the bigger triangle that's similar to that, where this is the piece we're actually looking for. That's my x. And then the bottom, I'm going to have to add up both of those to get 315. Now it's not too bad. I can go kind of little side over big side, little bottom over big bottom, little crisscross action going on. I had 230x was 37,800. Divide, and got about 164.3 yards for the answer for that one. So not too bad. This one's a little tricky. This one, we have similar triangles, but they're kind of cockeyed. They're not really lined up well with each other. So in the triangle below, ACB is a right angle. All right, so we got that drawn in on there. And then we also have a right angle here. E is a point on AC. Yeah, it looks like it. ED is drawn perpendicular. Okay. If AB is 9, so this entire distance here is 9. BC is 6. So right now they've given me the dimensions, two of the dimensions for this big triangle. If I just kind of step back, that's what I have for the big triangle. DE is 4. So DE, this little piece is 4. And then we're trying to find what is the length of AE. So there's no x's in the problem. Let's call it x. So when I draw this small triangle right here, this is the hypotenuse. So this is my x. Well, that matches up with the hypotenuse over here, and you might be like, well, how do you know those are similar? If you look at this angle, that angle is in the small triangle, but that angle is also right here in the big triangle. And since those angles match, and the other angle is 90, that kind of forces the third angle here to match for both of those. So now I know they're similar. It's just a matter of getting the pieces in the right spot. So this 4 is across from the one arc. So this is 4. And then across from the one arc, that would be the 6. So I know that this side should line up with this side. So now I can kind of set things up. I can kind of go, little hypotenuse over big hypotenuse, little side over big side. And now it's a pretty quick algebra situation. And I get x equals 6, which is the length of AE. So we are good to go. All right, number 5. This one I swiped from the Regents exam. So B is a point on AE, C is a point. We have parallel lines. So this right here allows us to do similar triangles because we have a parallel line there. We talked about that earlier. So AC is x minus 3, and BE is 20, AB is 16. So there's a possibility for some side splitter action. You know, I could kind of have piece and piece and piece and piece. But they don't give me CD. They give me AD. They give me the big dog. So a lot of times when they give you the big dog, it's probably easier to do divide and conquer. This piece is kind of tough. You could get that, and I've talked about it in class, so I'm not going to go through it in the notes. But you'd have to be careful on your subtraction there and distribute. But I think it would be easier to just do big triangle, little triangle, and then compare those, because the big triangle is 36 and 2x plus 2, and the small triangle is 16 and x minus 3. So I don't even have to really figure out CD to do this problem. So I'm just going to go big over little side, big over little side. Do a little shake and bake here. 36x minus 108. Just did that. Then the other way is 32x plus 32. And a couple moves, subtract the 32x, add the 108. That would be, what, 140. Divide. So x is 35. Now, I got to be really careful if this was multiple choice, because I think they'll try to trick you, because we have to find the length of AC, which is not 35. I have to put my x I found right there and now subtract 3 from it. So it looks like AC is actually 32. So if you put 35, you'll get most of the points, but not all of them. All right, a couple problems here at the end. We have the old right triangle altitude. So remember, there's a shortcut on this. The altitude of a right triangle that goes with the hypotenuse, that is the geometric mean. It's a special type of geometric average, but you set it up with a proportion on the bottom and the top. It's going to be a number between 9 and 40, but it's a special number that's proportional, so that 9 is to this number as that number is to 40. Cross multiply, you get this x squared is 360. Radical. And I'm going to cheat and look at my answer. That one was 18.97. All right, over here, I don't know this number, and I don't know this number. So I can't really just jump into the shortcut because I'm missing too many pieces. But I do see a little Pythagorean theorem opportunity here. I have a leg and a hypotenuse. So let's call this y, or maybe I'll even call it a for altitude. That might make a little more sense. So I'm going to go a squared plus 9 squared equals 21 squared. So a squared plus 81 equals, I don't think I did this one yet. Boom, boom, boom. 441. Gotta remember that. 41 is my lucky number. A squared equals, take away 81. That's going to put me to 360, I believe. And so it looks like this is the same as the last problem. The A is actually 18.97. Now, since I did the problem before, and I now know that that number is 18.97, I actually screwed up because I picked a problem with the same two numbers. If I hadn't done number 6, though, what I would do is, since I know the altitude, I can put it in both places. I can put the altitude here, and I can put the altitude there. I know the small number. I don't know the big number. And then I could just solve this. But since I have the answer from the problem before, I know that x comes out to be 40. Definitely will change that in the future, but that's the process. So always look for a potential Pythagorean theorem if you can't play the shortcut. There was also opportunities for similar triangles if you want to go that route. It's a little bit harder to visualize, but we went over in class. Good luck on the test. See you. Quick shout out to Carter's Games.